Welcome to the Algebra 2 benchmark review. This is part 1. This is probability. All right, question number 1. What's the probability of flipping a coin 4 times in a row and getting tails on all 4 coin flips? All right, so we want the probability of tail, 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 tail. Notice that's 4 events. Right? Now the probability of, well, there's 2 outcomes, right, on a coin, right? You can get a heads, you can get a tail. That's all you can do. Right? So one of those outcomes is our favorable outcome, right? There's one outcome that's tails, and there's 2 outcomes overall. So that means the probability of getting 1 tail would be 1/2, right? 1 favorable over 2 possibles. But we're not just flipping 1 coin, we're flipping it 4 times. Right? So the probability each time is going to be 1/2. These are mutually exclusive events. Right? What you get on one coin has no impact on what you get on the next. And if we have more than one event, we multiply the events together to find the probability. So the probability of flipping 4 tails would be 1/2 times 1/2 times 1/2, or 1/16. Question. And by the way, at the end there'll be a place for you to put any questions that you might have about any of the questions you saw. Right. Question 2. A spinner consists of 8 equal regions as shown. What's the probability of spinning a 1 and then a 2? Right. So we want the probability of 1 and then 2. Again, this is 2 events. So we need the probability of getting the 1 times the probability of spinning the 2. So I'm just going to put that probability of 1 times the probability of spinning the 2. Right? Well, there are 3 1s, right? So that's 3 favorable outcomes. There are 8 sections in this spinner. They're all supposed to be equally spaced, the best I could draw. So the probability of spinning the 1 is 3/8. There are 2 2s, right? So the probability of spinning the 2 is 2 out of 8, because there's 2 of them and there's 8 overall. And if we want the probability of spinning a 1 and then a 2, we're going to multiply the 2 probabilities together. Now you can reduce to make your number smaller, because you're going to have to reduce, either reduce in the beginning or reduce in the end, but you should reduce your probabilities. So this would be 3/8 times 2/8 reduces to 1/4, and that's going to be 3/32. That will be the probability of spinning a 1 and then a 2. All right, let's look at the next question. And so, by the way, these have all, the first 2 problems, and I think it's the first 5 problems, are coming from the multiplication rule, and there'll also be some questions that come from conditional probability, right? So 10 of the questions are from multiplication rule and conditional probability. They kind of overlap a little bit. And then 5 of the questions are from addition rule. All right, let's take a look at this one. A jar contains 12 chocolate chip cookies and 5 oatmeal cookies. You take a cookie at random and eat it. Then you choose another cookie. Are the events inverse events, dependent events, independent events, direct events? Right? Well, probability has nothing to do with inverse events or direct events. Inverse events, those are things that one undoes the other. Direct events, one causes the other. That has nothing to do with probability. Events, we can have independent events and we can have dependent events. If you do not change the sample set, it is an independent event. If you change the sample set, it is a dependent event. Well, you ate the cookie. There is now no longer 17 cookies. There's only 16 cookies. There's a dependent event because, put it down here, the sample set was changed. Right? There's only 16 cookies now. So now the next probability will have changed, right? Because we still don't have 17 total cookies. We only have 16 cookies. All right, let's take a look at the next one. You have a bag with 20 marbles, 5 red marbles, 8 purple marbles, and 7 green marbles. You're going to pick one marble, not replace it, and then pick another. What's the probability you will pick a red marble and then a purple marble? So this is the probability of red and then purple. Since this is more than one event, this involves multiplication. Anytime you have more than one event, it's multiplication rule. This is also an example of conditional probability because we're going to change the sample set because we did not replace it. Now there are a couple ways to figure out conditional probability, and they differ depending on the problem and how easy it is to figure out the new sample set. If you're taking something and not replacing it, we can just figure out the change in the sample set. It's easy enough to figure out, hey, we have one less marble and we have one less red marble specifically, and so we can solve it that way. And that's how we'll solve these where we have something happening without replacement. So we're going to find the probability for the red marble. There are 5 red marbles. There are 20 marbles overall. If you take a red marble out, there's only going to be 4 red marbles. And that means there's only going to be 19 marbles overall. So now your sample set has changed. So now when we multiply the probability of the red by the probability of the purple, our total number of outcomes is no longer going to be 20. Now it's only going to be 19, because there's only 19 marbles left. There's still 8 purple marbles, but there's only 19 marbles overall. Right? So if you have a problem, it's a probability problem, and you are taking something out without replacement, you're going to change the sample set. And the easiest way to do this kind of conditional probability problem is just to literally change the sample set. Change your total number, right, for the second one. If we were to pick another one, now there would only be 18 marbles, right? Now if you replace it, it's no longer conditional probability because you haven't changed the sample set. But if you change the sample set, remember to take one marble out of the total set. And let's calculate this probability. We should reduce. We have to reduce now or in the end, so let's reduce in the beginning. Oops. Yeah, that's 1/4. So 5 over 20, that would be 1/4 times 8/19. When you're multiplying, you can reduce numerator to denominator. So if I like, I can just divide 4 and 8 by 4. And that's going to give us a probability of 2/19. And there we go. And this problem is done. Okay? And I'm trying to go over them in a reasonable amount of time. If I go over them too quickly, please ask questions either in class or at the end of the video. You have one bag, so same bag here. You have a bag with 20 marbles, 5 red marbles, 8 purple marbles, and 7 green marbles. You're going to pick one marble, replace it, and then pick another. What's the probability you will pick 2 purple marbles? If we replace it, we're not going to change the sample set at all. Right? We're going to have 20 marbles for the first pick, and we'll have 20 marbles for the second pick. And we're going to have 8 purple marbles for the first pick, and we'll still have 8 purple marbles for the second pick. Now this is 2 events, so we're going to multiply, but our sample set has not changed, so we will have 8 out of 20, 8 purple marbles, 20 marbles overall for the first pick, and we'll still have 8 marbles, 20 marbles overall for the second pick. And we should reduce that. So that would be, both of those are divisible by 4, so that's going to be 2/5 times 2/5. Or 4/25. Right? That's the probability we'll pick a purple marble replace it, and then pick another purple marble. So remember, your sample set doesn't change if you replace it. Your sample set changes if you don't replace it. All right, so let's look at the next one. What is the probability of picking a queen or a spade from the set above? Now, when we see or, we're going to add the probabilities because it's only one event. We're picking one card, but we have more than one favorable option. All right, the queen is favorable and the spade is favorable. So when we see or, it's a add. When we see and, or we have two events, it's going to be a multiply. So and is multiply, and that also, I should probably put an X there. I should probably just write the word multiply. And that also applies if you have more than one event. Right? I'm picking a purple marble, and then I'm picking another. Matter of fact, here you can even see the word and in that question before, if I can manage to circle it with my left hand. There we go. All right, so this is an add. Now, to find the probability of queen or spade, and so if you remember, the U symbol there means union, all right, so that's or, queen or spade. We're combining the sets together. It's going to be the probability of queen plus the probability of spade, but we're going to have to subtract off, should have wrote smaller, the probability of queen and spade. Right? Because a card could fit into both groups, and we do not want to count it twice. So this is minus the probability of, I'll just put Q and spade. All right? So any card that's both a queen and a spade has to be subtracted out. Otherwise, we have counted them for the queens, and we've counted them for the spades. We would have counted them more than once. All right, so probability of queen, there are 3 queens, right? One, I shouldn't write in blue here, I'll switch colors to red. Does that one show up? Not really. 1, 2, and 3. We can kind of see the X's going on there. So there are 3 queens, right? So there's 3 queens. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 cards overall. All right, spades. All right, let's see how many spades we have. All right, so this is a spade. This is a spade. 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 All right, that's what a spade looks like. All right, so we have 1, 2, 3, 4, 5 spades. All right, so that would be 5 out of 12. But if we were just to say the probability was 8/12, we would be wrong because I counted one card twice. I counted the queen of spades for the queens, and I counted her for the spades. So I have to subtract off the probability of being a queen and a spade. Right? So the 3/12, I should move that over a little bit. The 3/12 was the probability for the queen. I'm going to move these numbers over so you can kind of see. The 5/12 was probability of, I don't know what this line is here. Oh, it's the minus sign. The 5/12 is the probability of picking the spade. Oh, I guess that plus is attached. The probability of queen and spade, there is one card that is both a queen and a spade. So we have to subtract that card off. So that means we have 3 plus 5, which is 8, minus 1, gives us a probability of 7/12. All right, and you can look and count. There are 7 cards that I've marked. One card just got marked twice. All right, so make sure if anybody is in both groups that you subtract off the probability of the both groups. All right, it's a little easier on this one where you can see, hey, there's 7 cards, it's going to be 7/12. but sometimes we just have probabilities, right? As you'll see in upcoming questions, and we can't just count, right? So you have to remember to subtract off the probability of both, right? All right, so let's go on to the next question, and do let me know after this video if you have any questions on these questions. You are playing a probability game with your friend. The probability that you spin an even number on the super amazing spinner is 1/4. The probability of earning more than 13 points is 1/3. The probability of spinning an even number and earning more than 13 points is 1/6. What's the probability of spinning an even number or more than 13 points? An or question, that means to add. We have one event, we're spinning, one spin, but we have more than one favorable outcome. Because we're interested in the probability of even or more than 13. Right? So to find that, we're going to take the probability of even plus the probability of more than 13. We'll add those together, but we have to subtract anything that's in both groups. So we're going to subtract the probability of even and more than 13. And so here's very similar to the last question, but you couldn't just count and see there were 7 cards. Right, in this question. The other question, you could see there was only 7 cards, so you knew not to count the queen of spades twice. But here, right, if you just add the numbers or you forget to subtract off the one that's in both, you're going to be incorrect. So the probability of even was 1/4. The probability of greater than 13 was 1/6. And the probability of spinning an even number and, wait, did I took the wrong number? Oops, sorry, I took the wrong number. My eyes went to the wrong place. Let's just go through this again. Right? So the probability of spinning an even number, that was the 1/4. The probability of more than 13 points was 1/3. Sorry, grabbed the wrong number. The probability of spinning an even number and earning more than 13 points, right? The one that's in both categories is 1/6. So the probability of being in both categories is 1/6. We have to subtract the 1/6 off. Before we can do that, we need a common denominator, right? Well, and the only number that 4 and 3 both divide, the smallest number that 4 and 3 both divide into, right, since they have nothing in common, would be 12, and that works for the 6. So let's change all these to a denominator of 12, right? So this would be 3/12. This would be 4/12. And I'm not going to go over how to change a fraction. I figure you can do that. And 1/6 is 2/12. But if not, ask me. All right, so the probability that you will get an even number or greater than 13 would be 7/12 minus 2/12, so that is 5/12. Right? So don't forget to subtract off anything that's in both categories. Otherwise, you've counted them twice. In a math class of 30 students, 17 are boys and 13 are girls. On a unit test, 4 boys and 5 girls make an A grade. If a student is chosen at random from the class, what's the probability of choosing a girl or an A student? All right, we see or, that is addition. All right. And you can be a girl and you can have an A. So we have to remember, if we want the probability of girl or A, to find the probability of girl and the probability of A, and subtract off the probability of girl and A. Right? Anybody who's in both categories. So the probability of being a girl, there are 13 girls. Right? So 13 out of 30. the probability and on a unit test, 4 boys and 5 girls made an A grade. All right, so we want all the people who are getting an A, right? So there are 9 students with an A. So let's add those in. The 9, so still 30 students in the class. 9 out of those 30 students got an A. But some of those A students are also girls. So these here, these 5 girls, they were counted with the girls. They were counted with the A students. So we're going to have to subtract them off because we counted them twice. We counted the 5 students in the girls. We counted the 5 students with the A's. We're going to have to subtract them off because we've been counted twice. All right, so then we have 13 plus 9 would be 22, minus 5 would be 16 out of 30. That should be reduced. That's divisible by 2. All right, so that's going to be 8/15. So the probability of choosing a girl or an A student would be 8 out of 15. All right, it includes the 13 girls, the 9 A students, but oops, don't forget to take off the 5 students that are both girls and A because they were counted in both groups. All right, let's go on to the next one. See how many more I have. I don't think I have too many more probability questions. A grocery store employs cashiers, stock clerks, and deli personnel. The distribution of employees according to marital status is shown here. Right? So we should always find, when you have a table, make sure you find the totals for everything. Right? So there are 13 cashiers, there are 27 stock clerks, there are 5 deli, and then going across there are 23 people that are married, and then there are 22 people that are not married. And that gives a total of 55. And you should have 55 whether you're adding up the on either category, either way. It should be adding up to 55. Did I? Hopefully. Now, unless they, yeah, because we're adding up the same people. Did I miss add? 23, 22. Okay. 27, 13. Why does it not seem like it's going to add up the same? Did I miscount somebody? Let's see, 30, I get 35. Oh, because one of my, no. Where did I add wrong? This would be 27, this would be 45. Oh, what did I put 30? No, it's not 55, it's 45. Oh my gosh. Whoops. And now look what I've done. You have one messed up hand and you forget how to add. And then you can't manage to erase either. Okay. I don't know where I got 55 from. 45. All right, so it should be the same whether I'm adding across the columns or down the columns. All right? It's the same people. So it should be 45 total people. All right, so we want to find the probability that an employee is a stock clerk or married. All right, so I'm going to write it down here. All right, so probability stock or married. All right, so that's an add because it's an or. We're picking one person, but we have more than one favorable group. All right, so the stock people, there are 27 out of the 45 people are stock people. The married, there are 23 out of the 45 people are married. But hey, I counted some people twice. All right, I counted the people that are both stock people and married. So these 12 people, they were counted twice. Right? I counted them for the stocks clerks. I counted them for the married. Right? I counted them this direction. I counted them this direction. So I have to make sure I subtract off the ones that are in both groups. So subtract off the 12 out of 45. 27 plus 23 is going to give us 50. All That alone should tell you something's wrong, right? Because there's only 45 people, right? You can't have 50. Right? And because we have counted them in more than one group, so we're going to subtract off the 12. So that's going to be 38 45ths. And believe it or not, that does not reduce. All right, question 2. Employee is not married. All right, so this is just a single probability. This is a single probability. It's not even an and or an or, because we're just looking for not married. We only have one favorable category. That's why it's not an and, or excuse me, an or. So we're not adding. Not married. All right, so there were 22 right here out of the 45. That's actually simpler than the questions on the benchmark. But rather than cutting it out, I just included it. The employee is a cashier or not married. So probability of cashier or not married, right? Which means we're going to add because it's an or. And it says not married, so we make sure to include the not married group, which we just had above. All right, so the probability of cashier, I'm going to switch colors. Probability of cashier, there are 13 cashiers, right? So that would be 13 out of 45. Right? And then not married, there are 22. We just added those up over there. 22 out of 45 are not married. And then we have to take out the people that we've counted twice. We have counted the not married cashiers twice. All right, so make sure you remove anybody who fits in both groups, because this fits in both groups. All right, so we're going to subtract off 5 45ths. And that's going to give us 13 plus 22 would be 35 minus 5. That's 30 out of 45, which reduces to 2/3. Both divisible by 15. Right? Let's move on. So hoping to keep this near part is probably a little longer than the other one, because there's 15 questions. All right, complete each statement. The probability of A or B. All right, so in the A group, we have those 7. I don't know how many there are overall. We should count. All right, you have to count this. The 7 here aren't in any group. So we have 27 and another 7, so that's 34 plus that 9. There's 43. What an odd number. I just randomly wrote numbers down. So there's 43. This is the total. So we just keep track of that. All right, so the probability of A or B. All right, there are 7 in A out of 43. In B, well, there's no overlap on that one, right? That's kind of interesting. I think I meant to write in the way I typed it up, A, B. Actually, I'm going to switch these. I have the right to do that. Because I think I wanted 2 overlapping groups and 1 non-overlapping group. There we go. All right, so A or B. All right, so we have the 7 out of 43 in A. In B, we have all of these. This is all in B. Woo. We have 15 out of 43. But some have been counted more than once. Right here, those 2 were counted more than once. So we'll have to subtract off 2 out of 43. So that's going to give us 22 minus 2 would be 20 out of 43. All right, I'm going to erase that so I don't get things confused. Now we're going to do B or C. All right, so here's B is all of those that we just did, right? So that was 15 out of 43. And then C includes those 7 out of 43. But wait a minute, we counted these 4 twice. That they're in group B and group C, so we have to subtract out 4 out of 43. So that's going to be 22 minus 4, 18 out of 43. And then finally, D or C. Well, D and C don't overlap. They are mutually exclusive. There is no overlap between D and C. So we just have to take the probability of D. There's 13 out of the 43. The probability of C, there's 7 out of 43. Add them together, and we get 20 out of 43. And that's that. Right, another one done. Let's see how many are left. I don't think too many left. I think this might be the last 2 for probability. Yes, 3. 3 more for probability. All right. A bag of marbles contains 5 blue, 9 red, 7 yellow, 3 black, and 6 white marbles. If you pull a marble out at random, what's the probability you will pull out a blue marble or a black marble? All right, so there are, how many marbles? There are, so we have the probability of, let's write it down first, blue or black. All right, so or means add. All right. And there's no overlap, right? The marble's not blue and black. It's either blue or it's black. There are 5 blue marbles, and there are, let's see how many marbles overall. 10, 21, 30 marbles overall. So 5 out of 30 for blue, 3 out of 30 for black, which is 8 out of 30, which reduces to 4 out of 15. Now, there was a question that asked you to find it as a decimal and a percent. So if you want to find that as a decimal, just divide 4 by 15, and that would be 0.2667. I think they only had 2 decimal places, so 0.267. I'll just put 3. As a percent, that would be 26.7%. Just multiply by 100 and put a percent symbol. All right, that one's done. How would you calculate the probability of picking 2 triangles from a box of shapes below if the first shape is not replaced? All right, so there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 shapes overall. And there are 1, 2, 3, 4, 5, 6, 7 triangles. So the probability of triangle and then triangle, this is more than one event, right? We're picking 2 shapes. So this is going to be multiplication. More than one event is multiplication. More than one favorable outcome is addition. Right? So this is going to be probability of the triangle. There was, what did I say, 7 triangles. So there's 7 out of 12 triangles. If I take out a triangle and I don't put it back, right, I don't have 7 triangles anymore. I only have 6 triangles. And I don't have 12 shapes. I only have 11 shapes. All right, so now we just multiply our 2 probabilities together, and that would be 42 out of 121. Wait, no, that's 11 times 11. 132. Oh, and I could have reduced that, which I should have reduced at the beginning. Right? I would have made it easier for myself if I just said reduce that by, divide both of those by 6. Let's just do that so I don't have to reduce the other one. And that would give me 7/20 seconds. Last probability question. Two sisters are buying a car from a lot. There are 75 cars in the lot. There are 20 dark blue cars, 45 light blue cars, and 35 black cars. What's the probability that both sisters buy a blue car? So it's the probability of blue and blue, and they didn't specify whether it was dark or light, so we'll have to add those together. All right, so the first sister has 45 plus 20, they've got 65 blue cars out of the 75. Whoops, did we misadd? That's too many cars. All right, well, just the number there. Oh, I must have thought I had 100 in there. All right, so now it's 100 cars, sorry. All right, 100 cars. So 65 out of 100. Once the one sister picks a car, both can't have the same car. There's only 64 cars left, 64 blue cars left, and 99 cars overall. So don't forget that if you not replacing, to reduce the number. All right, and then I just have to multiply those together. So, and they would reduce. I don't know what 65 times 64 is. 4160. Well, we could reduce the zeros and divide by 2. So 208 over 445. All right? And that's going to be the last of the probability questions. If you have any questions about these, then just write that question in the space that follows the podcast. All right, see you later in the trig question, the trig review. Bye for now.